the title to my talk is React moving forward. I believe that after, we could say like after React 16.7 or whenever hooks actually land in an official version, currently since it's only alpha, I believe this is going to change drastically how we are writing React components. If we have a chance to compare a code base of a new project in React 17 with a code base back in React 14 or 15, for example, I think we're going to notice that there are new patterns emerging, there are new ways of doing things. So this is what motivated the title, to say, you know, React moving forward, what are we gonna start seeing and what are the new things that are coming up? So the new things that are coming up is React Concurrent, Suspense, and hooks. I believe React Concurrent Suspense has been around since the beginning of the year, and everybody has sort of heard of it at least. You know, React Concurrent is this new architecture that it was codenamed Fiber previously, and while Suspense, it's like the possibility that React Concurrent, you know, enables us to do, and together with hooks is this new API. So everybody knows what are hooks. Everybody has heard of it. I was very surprised of how much reaction there was in the whole community, right? Everybody, like Twitter went on fire. It was pretty exciting to be part of a community like this, where everybody's very interested into the new things. So the hooks is this new proposal of React features that enables us to use React features without using classes, right? And of course, everybody knows this is currently alpha. Yeah, I'm lagging over here. Is everybody hearing me fine?
Yep, I do.
Yep.
Good, thanks. So the new APIs that are introduced with React hooks, these are the new APIs. I'm not gonna enumerate each one. I believe everybody probably has already taken a look into the React documentation and seen this. I do plan on, though, on showing this one by one. The use state is the one thing that, you know, has everybody very excited. Use state and use effect, basically, because these two create and enables us the ability to use functional components in a very easy way, the same way we would use class components. So if we take a look at some code here, for example, here I have a simple functional component that is rendering a couple of things. And I'm using use state just to have a toggle here to toggle some modal. So this is like really, really simple. It drastically has reduced the boilerplate, the code that we are writing. If we had to use classes, and in cases you were not using class fields, for example, you would need to define a constructor and do this dot state something and etc. The state would have to be an object. It could not be a primitive value. So all these things would have to be done for you to just have a is modal flag. So, you know, the use state is really, really, really cool, I would say. Use effect is a way for us to pretty much hook into multiple, not hook into, but react to multiple effects of during the component lifecycle. And I hate to use the word lifecycle because it's still part of our vocabulary, but it's about, you know, the phases that the component is going through, and specifically in the functional component. And we're gonna dig into this in a very little, and I'm gonna show you some other things. Use contest, just a way for you to, you know, connect into the contest. Use reducer, use memo, use ref. Use memo is pretty much a way for us to memoize some function. I'm sort of jumping a little bit because I will go very deep into each one of them. That's why I don't want to get too attached to details right now. But if we look around here on my code, you will see a use memo example is just a quick way for us to memoize some function that you are defining in your functional scope. Like, for example, here I have a card list, right? And I'm gonna sort my data. This is a very common approach that we take, is to pass the data we are receiving and do some sorting. And this is done in the render function, right? Inside your rendering scope. In order, the bad thing about this is that every time we have a re-render of this class list component, that data is gonna go through your sorting algorithm. So for you to make this more efficient and optimize it, you can simply wrap it with the use memo and pass the function that you're going to use to the whatever expensive computing algorithm you have here. And you need to pass the, as a second parameter, you pass the values that this depends on, in case, right, you only want to renew or invalidate this cache data when these two values have changed. So that's the use memo. Use ref, it's very similar to forward ref that we have used before, so I'm not going to go into it. Use imperative methods and the use mutation effect and use layout, these are like the more advanced features that we have, and it gets a little confusing. Use imperative method, I have another example here that implements it. It's just a way for you to sort of override the reference to a component. Take, for example, this screenshot that I have over here. Pay attention at the bottom. We have a function user component, right? And this user component is rendering an input. Is everybody following? And what I want to do is get the reference of the input that is inside this component input. So for me, so technically, this is what we want to do. Just that. We just want to get the reference to this input. But the problem with this approach, with simply getting ref and just doing a function to forward the ref, is that you are going to make available to this parent component over here, you're going to make all the references, all the methods inside the reference available. So for you to override that, for you to only make certain methods public, you can use the use imperative method, using imperative methods to sort of override that, and only and like the ref that this guy is getting over here is only going to have focus inside of that object. It's not going to have all of the other references of the input. So it's like I believe, like I'm not sure if Dan had mentioned this, but someone had mentioned somewhere that this is mostly going to be used by library maintainers, because maybe you want to provide some a reference of some component, but you don't want everyone to have access to everything. You just want to have access to some specific methods. So this is a way to do it. So it gets a little, it's very peculiar, it's very specific. Use mutation effect and use layout effect. Now this gets a little confusing because it's like, it's the place where you're going to make side effect functions that is going to manipulate the DOM. That you're either going to need to mutate the DOM or read the DOM, and etc. This is where you're going to do this. Previously, there wasn't much of a rule. Instead of that, you would get the reference to the DOM, or you would access the DOM, and you would do things there, and anywhere inside the life cycles of the classes, right? Now we specifically have use mutation effect and use layout effect for that. I believe that these two APIs, we can have a talk just about these two, because it's pretty interesting on why they exist. Like, for example, this was taken from the docs. Use mutation effect is pretty much happening as React's DOM is making its manipulation. So it's usually recommended for us to use it when we're going to mutate the DOM, but not actually read the values, because when you read the values, they are being mutated at that instance, so you can't really trust those values. While the use layout effect would be for after the DOM's manipulation has happened, so you can actually read the values from the DOM that were recently changed. So like I said, there are very specific use cases of this. I think like this is going to be very useful for me when working with React Native, where we need to determine certain things on scroll events, and this is a very interesting API. One of the things that came up during while hooks came out, everybody was talking about hooks. And this is how it felt to me at first as well. It was everything was all very magical. Just declaring a use state and then you had state was something that didn't make much sense of how this was happening behind. This guy, Jamie K, he did a very, very, very low level explanation, like a very simplistic explanation of how this works. Just imagine that on every component render, internally in React, it's calling an internal function, and each node or each leaf of the tree sort of has its own state. It's put it inside of like a list array, right? And so that's like sort of how it works, is when it starts calling the function, it registers all the hooks it has inside of that scope and it saves it. That's how it knows which function has which scope or specific which state. Of course, like I'm just like giving a very, very basic overview. It does not explain the architecture behind it. Unfortunately, React does not provide the architecture to us. Like we can't find that in the code base. We'll have to maybe dig through node modules to try to understand. So it's a little bit complex to explain it, but it's not magic. It's just using function scopes to declare it. So one thing that I wanted to approach in this talk and to think about is because we have a way of thinking, right? We have been working with React for a couple of years, and we have constructed a mindset of how we're going to solve our problems. And usually we would solve complex problems using classes. So what I want to do is I want to answer this question: how do hooks substitute the classes, states, and lifecycle methods? How are we going to do the same things we were doing with classes? So usually classes, they come with 4 different lifecycle phases, right? There's mounting, updating, unmounting, and error handling. Everybody here is experienced developer, and everybody knows all the methods. So I'm not going to enumerate them all. And there is error handling as well. The only one that we cannot reproduce using hooks today is error handling. These static get derived state from error and component did catch. This is something that is only provided still for classes. And there is a tweet, there is a comment of Dan saying that they do pretend to add this support for this in hooks as well. So there will be a future where pretty much you can replicate 100% all the functionalities of classes using hooks. So how can we do the same things using hooks? Let's say we have a constructor, right? Usually we use the constructor to define the initial values of a state. Technically, just passing the initial values to the use state function, that's pretty much how you would replicate that functionality. Component and mount, useEffects takes a second parameter, and it's like an input identity, right? It pretty much, it determines if it's going to re-render based on these values here. If you don't pass anything to it as a second parameter, it's always going to call the useEffect function every time the component re-renders. And it's very important to note that the useEffect is actually called after the component, after the React internal function finishes rendering the component. So, so pretty much if we pass an empty array, useEffect here will only be called on the first render. It won't be called anymore afterwards, and it will work as a component did mount. So that's just a way for you to assimilate this component method. Component did update, if you didn't pass anything, it would be like a component did update together with a component did mount, because it would render on the first, you will see the useEffect being called on the first time, as well as on the sequence on the other times. Component will unmount in case you need to call. Actually, I should have put it here a empty array as well. But in case I just need a component will unmount, you can return a function, and it pretty much gets called when the components unmount. So it's like a cleanup function. Usually, this was presented by Dan and afterwards by Ryan as a way for you to hook into like side effect code, like code that you're gonna listen to some events or some stuff like that. And you're gonna need to clean up these possible memory leaks, so you can return a function that does that inside of the useEffect, inside the useEffect's first parameter, I mean. Now, get snapshot before update and component data update. Usually the first one would read from DOM and return the results to component data update, right? So like, I've never actually used this in production, get snapshot before update, but just for those that don't remember, get snapshot before update is just a way for you to sort of read values of the DOM very specifically before the update occurs. Actually, like it's a little bit confusing sometimes because we think that every time a render function gets called, we believe the component that React has already painted this to the screen, and this today is not really true. Specifically after React concurrent, that's not always going to happen. Every time a render gets called, it goes through a computing phase inside of React before it gets painted into the screen. So the logic around this is that between these two phases, between painting something into the screen to the DOM and after the rendering gets computed, we can do things. We can read DOM layouts. We can update things if we want. And get snapshot before update was pretty much a way to do this. And usually when we used it, it would be used together with component data update. Use mutation effect and use layout effect is pretty much a replacement for that. One thing that is very, very cool to notice is that we used to explain React saying that React was very declarative, right? But yet these component lifecycle methods, did mount, did update, and etc., they weren't very declarative. They were very imperative actually, because we were telling exactly, we were saying something in a specific, we were declaring exactly how it was supposed to, what was supposed to happen. And these new hooks APIs, they are a lot more declarative than in comparison to the life cycles before. So this is something interesting to know, is that React is actually going towards a more declarative approach here. Now, the last one that I'm missing here that you guys didn't see me mention is the should component update. So the should component update, there's no equivalent in the hooks. The equivalent is actually an API that was provided by React, is the react.memo. Now react.memo enables us to sort of do a should component update on any component now, specifically on any functional component. So that is a different solution for should component update. So as you can see, with these basics, with all these, with the hooks APIs and with this memo API, you pretty much, you have in hands 90% of all the solutions that we would need with classes. So it makes writing classes almost like unnecessary. Now the next thing I'm going to get into is what is Suspense, right? So I mentioned hooks. Everybody is very aware of hooks. Everybody heard of hooks, and there is Suspense too. It was together. It was announced. Everything was together here. So what is Suspense? Suspense is pretty much deferred rendering. To explain deferred, because that was, I gotta admit, that was a new vocabulary for me this year that I learned. Just a second, let me drink some water. So Suspense is deferred rendering. It's just postponing something. It's just not rendering when right away. Maybe you want to hold up the rendering until it's ready, right? So that's Suspense. Now Suspense was enabled together, will be enabled together with React Concurrent, and that's going to change a lot of new things. That's going to change, not new things, but that's going to change things. And new things will emerge with that. New patterns that will emerge with hooks and Suspense. And why hooks and Suspense? Because not only Suspense and Concurrent will emerge new patterns, but together with hooks, new ways of writing components will emerge. And this is what my focus of this talk is all about. This is when we get into the code. So I created this component here, is not a component, sorry. I created this web app, very simple web app. Let me lower this here, there you go. So welcome to React moving forward. This app actually implements React Concurrent, Suspense examples, and hooks everywhere, right? So we got this hooks everywhere and suspended components, and this component called fetcher that I'm gonna talk about in a little bit. And the first thing I want to show you is suspended components. So what are the things that are going to emerge with Suspense. So here, this suspended components, if I click here, I'm going to show first the rendering. And in this moment, React Concurrent is not turned on, okay? So this is React 16.6 alpha, 16.6 alpha right now. This is what you would get if you started using Suspense. This is an example without Suspense. We are fetching some data, right? So let me open this up. So we are fetching some data. There is a loading screen. Wow, that's normal. That's what we have doing all these years. Now this is React with Suspense in 16.6. Again, there is some data loading, and I'm showing some loading screen. Now with React without concurrent mode turned on. Now React with just normal Suspense acts just like a placeholder that will substitute, that will either render a spinner, that will either render the fallback or the actual component. It's not going to do any suspending, okay? Remember that suspending is postponing some rendering. It's just doing an if-else. So before React Concurrent, now this is very important that you understand this. So before React Concurrent, we're not actually doing any suspending. We're just doing ifs and elses pretty much, like in a very, colloquial manner of explaining this. And so if I put here another example, this is the same thing. I'm using a Suspense component around this with React Cache. So these two tabs over here, they are rendering different components, but they are sharing the same React Cache resource. So that's why when I switch over here to with, there's not going to be any rendering. You see that was right away, because they're just simple caching. Now, if I reload the data here, you're going to see again the spinner rate. If I turn on the concurrent mode, now this is where things become very interesting. Suspense takes a max duration, which is pretty much how long it should wait before it displays a fallback. When I turn on concurrent mode, and I come here without, and then I go to with, right? I'm going to go there for the first time. We are not seeing any spinners anymore. If I come here again, and I'm going to reload the data where previously we saw the spinner, now we're not going to see any spinner. And you can pay attention down here that every time I reload the data, we are not seeing anything happen. Just the component is just updating. So this is React Concurrent in action right now. I'm going to turn off React Concurrent again, just so you guys can see this. So right now, I'm going to, as you can see, so what does React do with React Concurrent together with Suspense? Like I said, when you pass a max duration, it does not display the component until this max duration is over. But how is this happening in the code? So the component without any Suspense is just pretty much fetching the data, right? And I'm using hooks to fetch the data. So in case you want to see how do you fetch the data with hooks, I'm using a custom hook here. Just pay attention that it is a good practice to name your custom hooks with use in the beginning. But then again, it's also good for you to know that custom hooks, you can actually name them whatever you want. It's just good practice for you to, they will work if you use a different name. But ESLint will warn you in case you are using the new React hooks ESLint checker. So without Suspense, I'm just going to use hooks here to fetch some data. And to do that, I'm going to create a use state and then pass a use effect. Since what I want to do here is pretty much how we have always done fetching data with components, with class components, we usually put the fetch inside component amount. So remember that if I want something similar to that, I just pass a use effect and I pass the empty array so that this only renders on the component, on the first component mount. And then I'm returning the data here. And here's the data in use and I pass it down to my list. Okay, everything here, nothing new, just using hooks. Now, what about with Suspense? So let's go now with Suspense. With a simple Suspense component, what we're gonna do now is that we're gonna read the data. But what is this read? We're using an API that is also in construction for React Cache So if we look here, we are getting the Google News resource. Now, Google News resource is returning an unstable create resource API. This API is being provided by the React cache. This was named differently. This is the library that Andrew is working on specifically, Andrew from the React core team. And in this guy here, the create resource, he is pretty much taking the promises that you are returning to them and either throwing or resolving things when they are ready. Now, remember that that Suspense pretty much works with you throwing an arrow, sort of not throwing an arrow, but making a throw inside of the render. And then the Suspense component here sort of catches that. You know, you made the throw and the Suspense component catches that throw. It's the same mechanism that component did catch implements. It's not really component did catch, is it? It's component did catch, yes, that's correct. It's pretty much the same mechanism that component did catches uses. So every time you make an error boundary and the component, the whole app will not stop working because of that. So create resource pretty much does that for us. You return a promise to it, so fetches a promise, and inside of it, it determines when to update Suspense or not. And so Suspense sort of listens to these throws in their child components, right? And when the data resolves, it renders the component you wanted to render. So in this case, in my with Suspense, I want to render the use list. And when I do Google News Resource Read, if the data is not ready yet, it's gonna throw. And during that throw, Suspense is going to determine either to wait for 2 seconds or to display the spinner. That's what's pretty much happening in the background. And then after the 2 seconds is gone, it's gonna show the component here if it's ready. If it's not ready, it's gonna show the spinner until the component is ready. That's pretty much Suspense as it is right now. And another example I have here is Suspense with reload, right? And I'm pretty much just fetching data. I'm fetching data around and I'm keeping some state internally just so if I want to reload something or not. And this is just a flag so that I can create a new resource. Now, remember that each resource is a cache of data. So you have to override the existing resource. Unfortunately, the create resource does not yet provide us a way for us to simply refetch. So my approach was to simply just override it with the new cached resource. This is pretty much this is what will come up now. With Suspense, you're going to start to see data being fetched alongside the React components. So if we just pay attention to the with Suspense example that I have over here, this is a very simple API, right? This component is simply just returning a DOM component here that just renders UI, and it's just reading some resource, and that's pretty much it. So this is going to simplify a lot of things. Now, the one big thing though that we noticed when I started to see this is that this is not really how we do things though. We don't normally fetch the data at the component, at the UI level, and simply keep the data over there. Usually this is, if you are working on a big app, this is going to, we like to separate things. We like to maybe have Redux and fetch the data in a separate place, get the information and keep this data completely separated, and make the component simply just, if you're using Redux or if you're using MobX, you're simply connecting the component to that data and receiving the data. When you're doing this Google News resource read here, you're keeping the data in the Google News resource. So, and you're most likely going to keep this Google News resource near your component. So this is where it starts to diverge with what we're used to doing, right? Now, how are we going to share then data at a top level, like we used to do with Redux? How can we simulate the same approach? A way for us to simulate the same approach, I have an example here. and I can't see the top because of this thingy. Can I remove this? I don't think I can, huh?
You should be able to drag it. I think it's a draggable.
Oh, perfect. There we go. All right. So here we have classes view. And in this case, classes view is not actually fetching information outside, but it's being provided, it's actually under the class's context provider. Before I show this though, I'm gonna show a very simplistic approach. I've created a user provider, a provide user. And this provide user uses the contest API together with use state to provide a shareable state across your app. So what this pretty much does, it initializes a contest, right? You initialize a contest. And inside your contest provider, you keep some state around. This was already possible with classes. This is something we used to do with classes. I have done this with classes. And this is how you would share state with classes, right? With using the contest API. You would have a class, and inside this class there were some state, and then you would initialize some the contest API and share that throughout the tree. This is a very simplistic approach, just using use state, and then I'm passing down the values for state and dispatch. Now, pay very close attention to this part here. At this moment, I'm actually just making one provider. But in the documentation of React, they actually suggest you to separate this into two providers, because maybe you have a component that only needs the dispatch or the set state, and this dispatch and set state. And if you're connecting to just the dispatch, if there is an update to the state, it's going to re-render all the subscribe bit components. So this is something that there was a comment as well in the request for comments in the issue that they were complaining about this, that the subscribe components, this is something a little bit more related to the contest API than to actually hooks. But we would prefer that if I connect my component to the use contest provider here, and I'm just using the dispatch, it should not update if I'm connected just to dispatch. It should only update if I'm connected. It should only update if the information that I'm connected to has been updated. So this is something that can be improved here. Just to note my example. And in this case, I'm using this API inside of this ask name component, this functional component ask name, and I'm consuming the contest API using the hook called use contest. Now this is a very simplistic way. I'm just getting the state back in dispatch, and then every time I want to change something, I do it over here in the onChange. Now let's say you don't need something like a Redux, right? You just want to share a object model around. This is probably what a lot of people are going to start doing, is just providing a simple contest API using the use state hook here. This makes it for a simple approach, and we can consume this anywhere inside the tree that we are wrapping the use contest consumer, or specifically provider. Actually, if I search this, you will probably find that I have this at the top level of my app. So anybody under here can consume this information. Very good. Now, the second approach that I have is with this classes contest provider. Now, the classes provider, so I have a provide classes, is a little bit more complex. I know you're gonna notice something here that for those who are familiar with this, I'm using TypeScript in this example app. And one of the reasons that I'm using TypeScript is because my topic was React moving forward, right? And I have a very strong opinion about using static types with JavaScript. And I believe that with the advent of TypeScript and how it has improved, I strongly believe that everybody who's very serious about front-end development right now is probably going to be using TypeScript. And thanks to one of the guys who is also in our collective, Bruno Lemos, he made a pull request that included TypeScript configuration to the Create React app. So today, if you want to get started with TypeScript, it's as simple as pretty much just typing npx create react app and passing the name of your app and passing the TypeScript option, and you will have a React TypeScript configured app. So this is why I use TypeScript here. And I can show you how powerful it can be, an application that uses TypeScript together with the contest API and with the use reducer. Now, the use reducer, everybody heard of it. It follows the reducer architecture. So you can pass an initial state, a reducer, and even some initial actions if you want. The reducers is pretty much going to reduce your state, right? It's going to check for the action type and determine what to do based on that action type. So this is an example of how you would have a Redux-like using hooks, use reducer, and the contest API. And the very beauty of this is how easy it is to consume this. If I show you the classes view, I'm consuming this inside of the class list. Pretty much if I want to connect my component, my functional component class list, if I want to connect it to that hook store, not that hook store, but that class store, right? Because that's in the contest API. That's all I have to do. I have to just class state equals use contest. You don't need a connect function wrapping your components. And what I really like about this is usually when you are doing apps in Redux, you would have a global store, and inside of this global store, you would have many smaller models, right, representing different parts of your app. Leveraging the use reducer here together with the contest API, it enables you to sort of modularize this and make everyone separate from each other. Nobody's going to be connected here. I can have a state just for my classes. I can have a state just for my user. And if I need to consume it somewhere, I can hook them up. Now, one thing that I thought about was, okay, but that's still not how we are dealing with complex apps. Usually, we are dealing with complex apps using, like, for example, Redux Sega, so you can handle all the side effects, right? You are dispatching an action to fetch some data, and then after you get the data, you update your state. Now, all this can still be done. And this can still be done with your reducer. You could create a middleware for this and just get all your dispatched actions, right? And then decide what to do with it. You can direct some actions to Redux Sega, for example, and handle it there asynchronously. So all of the things, all of the APIs that Redux has around itself, it's still possible using the contest API together with the use reducer approach. So this is something very interesting. I'm not saying that this is like the best way to do it, but it enables new possibilities. Now, a very cool thing about the way I wrote this is that I'm using TypeScript, right? And I'm typing everything. I have an action here, and it takes some value in param that's going to go to our payload. And I'm defining some generic types. I'm defining the type of the action and the type of the payload here. Now, the very cool thing about this is that when I'm working and I'm very, very focused on what I'm doing, this enables us to work faster without worrying about errors. Take, for example, when case the action is a class.add, I know that there's only a class here. If I remove the class and then I try to access, I don't know, maybe the name, because there is a name over here, right? It's going to throw an error. It's going to say, hey, there's no name in this payload. There's only a class in this payload. So this is like why it's really beneficial to work with TypeScript together with these APIs. So that's pretty cool. But if we started coding, so the big thing that I started to think of is like, okay, if we started coding like we are coding with Redux, right? So we're gonna keep our state separated in a contest API that uses use reducer. So like I just showed you the example, and I'm gonna consume it this way. How are we going to leverage the Suspense API? How are we going to use React Concurrent for our benefits? So this is the next part of things. What are the possibilities here? How can we integrate things? Because if we look at the Suspense examples, we are seeing that the data is being collocated at the same level of the UI. And this is different. This is not something we were used to. Although this is more common in GraphQL clients. If you're using Apollo, if you're using Relay, it's very common for you to declare your data dependencies at the component UI level. More specifically for Relay than for Apollo, that is. So this is not something completely new, right? It's something that we're just going to continue to do this practice. But how can we improve this approach? And because no matter what, if we follow this example I gave you here, we're still doing things repeatedly. I'm having to declare suspense at the top level. I'm having to fetch the data manually here. I'm having to start a resource, right, at the top over here. I'm starting a resource and I'm going to read it afterwards. So all this is very imperative. How can we make this better? Now, this is where I thought about it, and this is something, this is just an idea though. It's nothing, nothing concrete, just an idea. So I believe you guys can comment and tell me what you guys think. But one of the things I thought about was a fetcher component. Now, you can see in this example, I don't have concurrent mode turned on, right? So you saw the loading phase going on, and you saw the components appear. If I turn concurrent mode on and I go to the fetcher, you would see that that is really, really fresh. That's really nice. And this component fetcher here that I created is, let me show you the example. This is pretty much it. The fetcher component is similar. I got inspired by the create query renderer in Relay. In Relay, we have like a top level fetcher, right? That takes the data requirements, which is the GraphQL query, and then it renders the data based on the results. So this fetcher does something very similar. It takes a URL, it takes a map data for you to map the data you are receiving, and it takes an on-render. On-render is similar to like an on-success. And sorry if I didn't make the types correct. I did this like 3 hours ago and I did it really fast. And it takes an on-render, which is similar to like an on-success. The on-fallback, which is passed to the suspense component, right? In case the max duration goes through, there is a on-fallback. And in on-failure case, we have the URL does not go through. The request does not go through. We have an on-failure to display the error message here. And then I created this save data, which again, it was something I just did it really quickly, but after I even thought about it, this might not even be required. The reason why I thought about the save data was that, like we were saying, we like to keep data separated, right? We want to keep the data saved somewhere at a higher level so that we can use it elsewhere. So this fetcher lets you collocate the data at the same level of the component UI, but it lets you also lift that data up. This fetcher does not save the data in the state. It saves it in cache, in memory, because of the resource, the create resource API, right? So if you want to keep that at a higher level, you can sort of map the data using the save data here. In case I'm going to receive the data and I'm going to save it to Redux. I don't know, save it to my contest API, right? My data. This is just an example of that. Now, how does this work internally though? Let me show you internally. So what's going on internally here? So for me to make use the use state API, use effect, right? And component together with the data resource, we are creating a new data resource that is using the React cache, using the unstable create resource. We pass an URL and we do some things inside of it. And then we return the data resource down. The reason why I'm doing this, because in the first pass, when I declare the data here, when I'm getting the resource for the first time, the data is completely undefined. So at this moment, like in that first instance, you really don't need to do anything. And the reason why we are keeping some state around for is ready is because we do need to trigger the update. If we rely only on the reference of data resource, you all know that you won't trigger an update to the React component. And that's pretty much it. It's a very simplistic approach. Internally, we render inside of the suspense component an internal component that determines to render the data. It reads the data and renders the data. And this render here, the on-render, it's actually the on-render component you're passing to it. This currently does not have support for the on-fail area yet because it's still a little bit, this create resource is not yet ready. It's missing a few features, and I didn't have enough time to actually create my own create resource. But you guys get the idea. My main focus here is pretty much to show you guys a possibility, how we can do things. So could this be the future maybe? Are we going to have an approach more similarly to GraphQL clients where we are co-locating data requirements, right? Because this fetcher, when he calls this API and when he uses a specific map data function here, it declares to the developer that this component, the component that's going to be rendered here, requires these data. It's dependent on these data, right? And this is a very cool way. It's an interesting way. I'm not going to say it's the only way, the best way, but it's an interesting way to declare our data dependencies. So these, I got into those. I mentioned how we can do like a one-to-one example of hooks and class life cycles. I mentioned the should component update using React.memo, how it's similar, and what is Suspense, the new patterns that will emerge, like the fetcher component, the shared state with hooks, right? Using hooks plus the context API, you can have something with use reducer and be very similar to Redux. But all of these things that I mentioned, even Suspense, even React concurrent, if I show you the code for concurrent, how to enable it is very ugly. It's still not ready. It's something that is still doing. For you to enable React concurrent, all you have to do is instead of using the render, you're going to use the create root.render. So this is some like very mutated code that I just needed to make this logic. I don't recommend for you to use this on a production app or anything like that. This is just for the demo. Again, this is all still very new. Hooks are still in RFC. And it's incredible because if I open up, I'm not even going to open up this because let me see if it opens up. Yes, it does. There are over 1,000 comments in the RFC for React hooks, and it doesn't stop. It's even hard to follow this. There's literally a lot of people commenting, a lot of people suggesting new APIs. So I wouldn't get too excited about hooks yet. I would not use hooks. I don't recommend using hooks anywhere besides playing around because it's all very new. There are problems with hooks. There has already been issues that have been open, like for example, the use callback invalidates too often, and there are some other hooks there are some other problems that they're still talking about. They need to find out how to fix it and how to improve it. There are people there are very, I'm not going to say famous people, but there are some important people that we need to hear to, like Lee, for example, Lee Byron, who suggested something, a different approach, maybe passing the hooks instead of simply declaring it, importing it from React, passing it as a second parameter to the functional component. So there are possibilities. The use context, again, it updates all the connected components independent if the dependent value is updated. So I explained that before. So again, that's another problem. So all these things are open for us to comment, for us to talk about. And that's the beauty of open source. We have here in G2i a very strong collective. There are a lot of developers here. Everybody's very experienced in their area of expertise. I know many of you guys are very experienced with React, and everybody has an opinion. And I believe it's very important for all of you guys to share these opinions so that we can move forward in the right direction. That's like, that's like democracy. Everybody gotta chip in and we gotta determine how to do things better. But that's pretty much it. That was what I wanted to talk about. Maybe I wanted to mention a few more things, but I don't want to hug all the time. We already did 50 minutes, so that's a lot of time.